When completing the square when a is not 1, I want to do a quick review of what we do when a is 1. Remember that in completing the square, we isolate the constant on one side. So I'm going to put the 9 over here and make it -9. Then what we do, always when completing the square, we take half of the middle term, the coefficient anyways, -4, and then we square it to become 16. So this value that we add to the one side, we always have to add to the other. So in completing the square, this term here becomes the last term in the binomial. So this is going to become x minus 4 quantity squared, and over here -9 plus 16 is going to be equal to 7. And in solving this, what we're going to do is we're going to take the square root of both sides. So on the left side we have the x minus 4, and on this side we have the positive negative values of the square root of 7. And then isolating x, we have 4 plus or minus the square root of 7. Over here as well, doing the same thing. Again, we're isolating the constant, so I'm going to move that 6x term over the one side. So I've got x squared, now it's going to be plus 6x is equal to 8. And then, as always, we take half of that coefficient and we square it. So half of that is going to be a positive 3. And then when we square it, we're going to have 9 on this side, and so we have to add 9 on this side. So creating the new binomial, this is now x plus 3 squared on this side, and then we have 17 over here. Taking the square root of both sides, you're now going to have x plus 3 is equal to the positive negative square root of 17. Then isolating that x, we have x is equal to -3 plus or minus the square root of 17, or you could have said the negative positive square root of 17 minus 3. Now when we get to the values when a is not 1. So the first thing we're going to do, again, when we're talking about a is not 1, we're talking about the coefficient of x squared. So first of all, let's again isolate the constant on the one side. So I've got 3x squared minus 2x, and then I'm going to move it over there. It's going to become a positive 5. Now the next thing we're going to do is we're going to factor out a 3 out of just these two terms. So if I factor a 3 out of this term, this is going to become x squared, and this is going to become 2/3 x, and then we're going to have 5 over here, as always. And then we complete the square here. Now I have the beginning of a trinomial where a is 1. We're going to deal with that 3 in just a minute, but what we're going to do is we're going to take half of 2/3. So half of 2/3 is 2/6, or 1/3 if you will. And then we square it. And when we square it, it's always going to be positive. And what I'm going to do is I'm going to actually change this to be red, because this is what we did. So here's the thing. What we have to do is we have to account for the fact of what we actually added to the quantity. So up above here, when we added 16, I simply add 16 to this side. But what we have to keep in mind is that when I add 1/9 to both this side, I can't just say plus 1/9 over here. I didn't add 1/9, I actually added 3 times 1/9 to that quantity. So the other part of completing the square when we add this over here is we have to take this into account. And remember that I actually took 3 times that 1/9 when I added that to this side. So 3 times 1/9 is 3/9, or 1/3. So that's the other thing to keep in mind when we're doing this. So in completing the square then, we're going to have that 3 on the outside. This, not the minus 1/3 squared is equal to 5 1/3. That's the same as 16/3. And what I'm going to do is again going to isolate this binomial. So dividing both sides by 3, I have x is equal to, x minus 1/3 squared, and dividing both sides by 3, this is now 16 over 9. And if you wanted to see that, basically what I'm doing is I hit the wrong one. I'm multiplying both sides by 1/3 to cancel this out, and then I'm multiplying by 1/3, which creates that denominator of 16/9. 9 on the bottom of 16/9. There we go. And then we're going to do what we've done before. We're going to take the square root of both sides. So this is just a little bit more fraction work, usually. So I've got x minus 1/3 And then the square root of both the numerator and denominator is 4/3. And of course the plus or minus version of that. So then x is going to be equal to plus or minus 4/3 minus 1/3, which creates our two different values. So a positive 4/3 minus 1/3. I apologize, that should be adding 1/3 to both sides. So positive 4/3 plus 1/3 is equal to the positive 5/3, and a negative 4/3 minus 1/3 is a negative 1, and those are the two answers you have. So let's do the same thing here. We're going to take 3x squared. Well, it's already got the constant isolated on the one side, so let's isolate out, or factor out, excuse me, factor out the 3. And so again, to complete the square, we take half of this, which is negative 1, and then we square it, which becomes positive 1. So as we do that, then again, we have to remember that I didn't actually add 1 to both sides. I added 1 plus 3, or 1 times 3 to both sides. So that's how it becomes completing the square. Is we not only are we adding something to both sides, but you have to take into account this factor right here. So then we have 3 times, again, this center term creates our binomial, so minus 1 squared is equal to 8. I'm going to isolate my squared binomial, and then I'm going to take the square root of both sides. So I have x minus 1 is equal to the square root of 8/3, positive, negative. Then we're going to add 1 to both sides. So what we have left is we have a positive 1 plus or minus the square root of 8/3. And then we can rationalize the denominator if we'd like. So we have here, and mathematicians really like that, so we're going to do that. We're going to go 1 plus or minus square root of 8 over square root of 3, and then rationalizing that denominator. We're going to have 1 plus square root of 24 over 3. And then when, plus or minus, I didn't put that minus. And then simplifying the radical and combining like terms. I'll put a couple more of these steps here. So this becomes 3 over 3 to get the common denominator. This simplified becomes 2 radical 6 over 3. So you could have 1 plus or minus the square root of 2 square root of radical 6 over 3, or you can combine them all over the same denominator, which would be 3 plus or minus the 2 radical 6 all over 3.